Welcome to the Box Buffering Capacity app. My name is Matthias Sterlich, and I will quickly try to explain the functionalities of the app and how it might be useful to measure, or rather predict, the environmental conditions, the relative humidity within the box, within a given archival box in a broader environment. The app has two functionalities. Tab A allows us to calculate the environmental behavior for a box for which we have a set of measured data, so relative humidity within the box and outside the box for a longer period of time. And tab B enables us to calculate the environmental conditions within the box for a set of types of boxes that are typically commercially available. So let's have a look at a box for which we have a set of measured data for the past several months. I will not go into the details of how the file that needs to be pre-formatted for the purpose of our app needs to be set up. I will just upload a set of data that I have made available for this particular exercise. I have uploaded the data. I now need to read the data. Once the data is read, we can see that the app plots the external data using a red line, and the black line represents the relative humidity within the box during the same experiment. So we need to have several months of data for our given box, within the box and outside the box. Once this data is uploaded, we can calculate the so-called humidity index, humidity buffering index. Once the index is calculated, it is then provided in the tab called Results, and using this particular tab, we can see how our modeled curve, this is the blue curve, follows or not the measured curve. So the measured curve is the black curve, and the modeled curve is the curve that we have modeled using our algorithm. Based on, and we see that the agreement is pretty good. The index that we have set up is defined in a range between 0 and 100, and the higher the index, the better the buffering capacity of a box. Now what can we do with this index? Let's have a look at the Prediction tab. In this tab, we can model how this particular box might buffer environmental fluctuations outside the box, and let's say that those fluctuations are within a range of 0 to 50% relative humidity, so this would be plus minus 25%, and let's say that we need to buffer the internal environment within the box to plus minus 10%, so the total interval is 20%. If we predict the internal values, we see that the red line represents a set of idealized external fluctuations. The green line represents our preset acceptable daily RH fluctuations, and the blue line represents the modeled fluctuations of relative humidity within the box. And we see that the blue line exceeds the maxima and minima of the green line, meaning that this particular box doesn't fit the acceptable daily RH fluctuations, or just about doesn't fit. The truth is that daily fluctuations of plus minus 25% are incredibly high. So let's say we make this fluctuation slightly more realistic to plus minus 15%. And if the external fluctuations are smaller, then of course the internal fluctuations will be within the preset acceptable RH fluctuations, meaning that our particular box suitably reduces the fluctuations of relative humidity outside the box. We can also perform custom predictions, meaning that we can upload a file containing a set of relative humidities outside the box and look at how such a box might buffer the internal environment within the box. Once we upload the data, we need to read the data such that the data is plotted. And once the data is read, we then need to predict the internal relative humidity. And we see that with the environmental perturbation that we've seen before, the internal environment will be slightly buffered. So it will be buffered to an extent that is represented by the blue curve. So this is for an unknown box or for a custom box. If we want to examine how certain commercially available boxes might behave, we have a set of preset values available. We can either work with boxes that have been filled full of paper or to some extent with paper, or boxes that are entirely empty. Empty boxes are also useful to model for objects that are not hygroscopic at all. We can then either model freestanding boxes, so this would be a box standing freely on a shelf, or boxes that are stacked, meaning that their covers are immediately adjacent next to another. This, of course, reduces the active surface of a box. We can then model different types of boxes, either typical cardboard, coated cardboard, meaning that the cardboard is coated with a material that doesn't allow water permeation. We can model plastic boxes, typically used in archival and library context are polythene or polypropylene boxes. We can model the behavior of fluted cardboard or just simply coated kraft paper, which is also sometimes used to wrap objects in archival and library conditions. So let's say that we want to model a coated cardboard box, that ours is an A4 freestanding box and that it is full of paper. We can calculate the HA index, so the humidity index. We can actually also input various sets of values manually, but these are really just useful for box developers because we need to know exactly what the air exchange rate per day is and what for example, the water vapor transmission rate is, and we rarely know these values for any given cardboard or box material unless it's been purposely measured. We can then calculate the humidity buffering index. The results for this particular box are the following. The humidity index is extremely high. This is because the cardboard is coated. It doesn't allow the permeation of water through the walls of a box, which means that the internal relative humidity will be pretty stable. Let's see if that's the case. Let's use the same environment as before, so plus minus 15% in a day, and our acceptable daily RH fluctuation is plus minus 10%, so the total interval is 30% of external fluctuation, and the total allowable interval of internal fluctuation is 20%. Let's predict the internal RH, and we see that this particular box almost entirely dampens the external fluctuation. So much so that only a few percent of relative humidity plus minus is evident. We can input different data. Let's, just for the sake of comparison, let's look at a cardboard that isn't coated. Let's quickly calculate the humidity buffering index, and let's do the same simulation as we did before, and we'll see that the values will change slightly. This is because uncoated cardboard doesn't buffer the relative humidity quite as well as coated cardboard. If, however, we use a stacked box, we will see that the buffering capacity is improved again, and that's because the total surface area of a stacked box is much less than that of a non-stacked box. However, in this particular case, because the box is full of paper, the fact that the paper is contained within the box means that the internal environment is relatively stable. If we use an empty box, we will see that the results will be different. Let's see what happens in an empty box, so without any paper within, and we see that the fluctuations are higher, and that's because the internal environment within the box is not moderated or buffered by the object itself, which in the case of archival boxes, of course, is paper. If we want to use this particular box to explore how it might buffer the environment in a custom environment, we can again upload a file containing a set of relative humidities over a longer period of time. We need to read the data, and once the data is read, we can predict the internal RH within the box for that particular box. And we see that the buffering is pretty good. The rate of change within the box is much less than the rate of change outside the box. If again we use, for example, a coated cardboard, let's say this one, and if we say, let's say that the box is full of paper, and let's do the calculations again, let's do the custom prediction again, there, and we see that a coated cardboard box full of paper will extremely effectively buffer the external conditions and keep the relative humidity within the box very stable. I hope you find this app useful. It's been developed in collaboration between the Heritage Science Laboratory Ljubljana and UCL Institute for Sustainable Heritage within a European Union project called Apache. Thank you very much.